over the next 35-40 minutes or so, I would like to talk to you about strategic crowdsourcing networks for geosensing applications, but the applications here are not very important. What is important here is the notion of a crowdsourcing network. And we'll try to see how game theory and mechanism design could be leveraged in analyzing and also in designing such crowdsourcing networks. So to start with, I will try to provide several motivating problems. So this basically motivates the need for using game theory and mechanism design for making better and more effective use of crowdsourcing. In the second part of the talk, I will say a little more about how mechanism design will be useful in the crowdsourcing context. In the third part of the talk, I will try to provide an application where we have designed a crowdsourcing mechanism in a specific context. I call this as crowdsourcing mechanisms with known qualities, where the qualities of the crowd workers are already known. And finally, I will also try to say why mechanism design and machine learning will have to be used in conjunction if you want to come up with a complete solution to the design of a crowdsourcing mechanism problem. So that is in some sense the outline of my talk. So let me get started with several motivating problems. And the first two or three problems are problems in disaster management that I am currently working with the Defense Research and Development Organization. These are like dream applications where crowdsourcing could be used. All of you would have heard about the tsunami in Japan, Fukushima Daiichi nuclear disaster. So what happened here was in 2011, there was this problem to measure the radiation levels in different areas after the nuclear reactors they began to fail. So because they wanted to find out what is the extent of radiation level and also damage that was caused by the failure of these nuclear reactors. But the government agencies were simply not able to mobilize enough resources for doing that, meaning the human resources. So what was actually done was there was a crowdsourcing website that was set up, and they quickly fabricated very simple Geiger counters with which you can actually measure radiation levels, and then the citizens who are geographically spread over different parts of the country would use these Geiger counters and upload information about the radiation levels, and this information was extremely useful for the Japanese government to put in place several measures. And it turns out that in this whole exercise, resource allocation was very important. So the number of Geiger counters was an issue, and how these Geiger counters are actually allocated to different parts of the country was very important. And what kind of incentives must be given to all the citizens in order to upload the correct information was another issue. And it also you had to also deal with human beings here, and human beings tend to be very strategic, and they may or may not upload accurate information. The second example is somewhat similar. Here, the idea was to send rescuers to locations of the Haiti earthquake, which happened in 2010 or so. The problem here was that after the earthquake happened, the rescuers had to be sent to locations of trapped and injured victims. But then how should one collect the information about which parts of the country are actually affected was an issue. And here again, it turns out that what was actually done was local radio stations asked people to text disaster information, and that was later on aggregated by volunteers, and based on this information that was aggregated, rescuers were sent to some of the most intensely affected areas and so on. So this is another example of crowdsourcing. If it is done properly and effectively, can actually result in a social cause. A similar thing was attempted in the 2013 floods in Uttarakhand. Here what happened was a variety of media and social networking options were used, but they had limited success. But if you now want to be very successful in using crowdsourcing in disaster management operation, it turns out that you can actually use some techniques from game theory and mechanism design. Okay, so the other example which is somewhat interesting is in the healthcare domain. As you know, dengue fever is very prevalent in many parts of the country right now. In fact, a city like Bangalore itself was affected not so long ago. IISc has something like 4,000 students, and as many as 55 students were affected with dengue fever in a given month. So dengue is actually something that needs to be taken care of. So the idea here is dengue comes because of mosquitoes. All of us know that mosquitoes will have to be eliminated if you want to take care of dengue. But then how do you know where the mosquito breeding sites are? Right? This may look like a very simple problem, but then in a geographically distributed country, now if you want to find out where the mosquito breeding sites are and what is the intensity of this mosquito breeding site, this information can be extremely useful for healthcare service provider, and it turns out that this has actually been done by some of the governments in a fairly systematic fashion, where there are many steps involved here. First of all, you post specifications about what exactly is the information that is required about the breeding sites. Then you have to somehow advertise this campaign to collect information about the breeding sites, and then you have to identify the crowd workers who will actually contribute to the whole thing. And then the crowd workers will report about the breeding sites, and then you have to validate the authenticity of the information that has been obtained, and you take some action. And finally, you have to award some kind of an incentive to the crowd workers or the citizens who actually participated in the whole campaign. Now, you would see that there are many steps in this process. If you want to make this process very successful, then incentive design is going to be extremely important. Unless you offer incentives, nobody is going to give you accurate information. Nobody is going to spend the kind of effort that is required to provide information that is exactly required by any agency like this. So if you now want to design an algorithm or a mechanism which will make this crowdsourcing campaign here in this specific context extremely effective and also cost effective, then it turns out that you can actually use techniques from mechanism design to do this. My final example is another very simple example. So one can use this in the smart cities context. Now again, a city like Delhi or Kolkata or Bangalore, the pollution levels are very, very high. So let us say that you want to constantly monitor the pollution levels of a city, or let's say along a highway, along a national highway. So how do you do that? The best thing is to have a very simple equipment which is fixed on the top of a vehicle or a car, and that can measure the pollution level. And as the car passes along a highway or through various streets of the city, you collect information about the pollution levels, and then you report it to the pollution control agency. So here is a diagram which will tell you that along a highway, so if there is an office goer who starts from home every day and uses a vehicle and goes to the office, and then while going to the office he goes through a couple of highways, then you would see that these various intermediate streets that are traversed by this particular person, the pollution levels can be monitored automatically and then reported. And this way you are actually helping the state government or the pollution control agency to constantly monitor the pollution control. But then unless you offer an incentive to the players involved here, you are not even sure whether these things will be done in the best possible way. So after these examples, let's quickly try to study what would be issues if you want to make crowdsourcing very effective in this kind of scenarios. Okay, the first issue will be that the crowd, so let us call them as agents, right? These are crowd workers. Crowd agents are heterogeneous. Some of them will do the job perfectly, some of them may not have a skill level or a quality. And these skill levels or qualities are unknown to the planner, right? And sometimes these skill levels may not even be known to the crowd workers. Okay, the second issue here is that the cost for performing the task is private information of the crowd workers. The crowd worker has a certain cost for performing a given task, but this cost is known to the crowd worker and is not known to the social planner. So how does the social planner get to know the truthful valuation or the cost that a particular crowd worker has for performing a task is another very important issue. Then workers to be allocated the tasks so as to minimize the total cost of fulfilling all the tasks. You have to do it within a limited budget. You don't have infinite amount of money to do these things. So you have a certain budget constraint and you have to accomplish all this within the budget that you have. And many times the workers have preferences over tasks. What do I mean by that? For example, if in the case of pollution monitoring, so the tasks which are going to be performed by a player will depend on which highways that person is going to travel every day, right? So there could be a preference on the tasks that are going to be performed by a player, and then when you do the allocation, you need to take into account some of these constraints. And finally, you also need a minimum threshold accuracy from the inferred reports. So accuracy of the results inferred from the reports of the workers must be beyond a certain threshold, because if the information is not accurate, the actions that you are going to initiate based on the information that you have collected may turn out to be absolutely useless. So these are all issues that you need to look into when you want to deploy a mechanism or an algorithm to use crowdsourcing in the kind of social tasks that we have talked about so far. And it turns out that if you want to address these effectively, one tool that you can use is mechanism design. Now, the reason why you would like to use mechanism design is that the agents involved here or the crowd workers involved here could be very strategic. They hold on to some private information. They will not reveal the true quality of performing the tasks and so on. So you are confronted with incomplete information. And it turns out that if you really want to effectively and scientifically design protocols for making crowdsourcing more effective, you need to use game theory and mechanism design.